Hey there, Patriots. So I am actually going to walk you through the lesson on identifying if two triangles are similar by using the similar triangle theorems. So for your bell work, what I would like you to do, so what I want in these pictures, you are going to determine, are these pictures showing you a similarity theorem? Are they showing you angle, angle, side, 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 or side, angle, side? Remember, it's not only the location, so you're just going to look at the location for this because there's no second triangle to compare it to. So just look at the location of these two triangles and the three triangles and determine which theorem it would be. And then the next question is, after I prove two triangles are similar with one of the theorems, what do I know about the other sides and angles of these two triangles? So what do we know about the sides of similar triangles, and what do we know about the angles of similar triangles? All right, so let's take a look at this. Let's try to figure out if these two triangles are similar. And if they are, we're going to write a similarity statement, and we're going to say the reason they are similar. All right, so when I'm looking at this, what I'm thinking, when I'm looking at the triangle on the left, so I'm taking my big fat hand, and I'm covering up the triangle on the right. So I'm only looking at triangle ABE. And I notice there's two angles. So I'm immediately thinking angle, angle. Triangle BDC on the right only has one angle. But what I notice is we have vertical angles. So this angle here must also be 42. These two angles are the same because of vertical angles. And then I have an 85 and a 53. So they're not the same. But remember, if we have triangles, triangles must always add up to 180. Alrighty, so what I'm going to do is I'm going to try to figure out what one of the missing angles is. I'm going to try to figure out what angle E is or what angle D is. So what I'm going to do is I'm going to do 53 plus 42 plus angle E equals 180, and I'm going to figure out what angle E is. So that gives me 97 plus angle E equals 180. I will subtract 97 from both sides, and we have E equals 83. So this angle is 83. Is 83 congruent to 85? No, it's not. So these two triangles are not similar. Not similar is always an option. So we are going to say not similar. So let's take the theorem, if any, that proves these triangles are similar. And then we're going to write a similarity statement. Okay, so what I noticed right off the bat is I don't have any angles marked. I don't have any sides marked. But I do have vertical angles. So I'm going to get out my colors. I'm going to go boom, boom. Those two angles are the same because they're vertical. And then they don't have any other angles or wait a minute. They have that QR is parallel to VU. And remember, when we have parallel lines, alternate interior angles are always congruent. So boom, boom, those two angles are congruent. Boom, boom, those two angles are congruent. So now that we've got all those congruent angles, do we have similar triangles? Yes, yes we do. We have similar triangles because of the angle-angle postulate. So I know triangle QRT is similar to triangle. Now we've got to match it up. So I did Q, R, T. We did green, blue, yellow. So the next one needs to be green, blue, yellow in the exact same order. So green is going to be angle V, U, T, and they are similar by angle, angle. Notice we don't say angle, angle, angle. Even though it's all three angles, it's only two. We still say angle, angle. So you're going to give me the similarity statement, and then you're going to tell me why they're similar. Similarity statement and why they're similar. Okay, so when I'm looking at these two, what I see is if you cover up one of the triangles, so I'm going to just look at the big triangle, EFG, and I notice that two sides are marked. But again, all the way back from August of 2021, we've got vertical angles. So we've got, what I'm seeing is two sides and the angle in the middle. I'm thinking side, angle, side. But what we're going to, so to do that, I'm going to go long over long and short over short. We're going to go long side over long side, and I'm going to see, does that equal short side over short side? Well, my long side, oh, I can't use yellow, darn it. I've already used yellow, no yellow. So let's go ahead and use green. My long side is 70. My long side is 42. Then I have my short sides. Oh, 70 again, 42 again. Well, that makes it easy. And the reason it makes it easy is because 70 over 42 definitely equals 70 over 42. I don't even need to reduce the fraction. So I do know the triangles are similar. Triangle EFG is similar to triangle. Okay, so I went EFG, yellow, blue side, blank side. Yellow, blue side, blank side. So I'm going to go yellow, blue side, blank side, and that is similar by side, angle, side. Boom. How about this one? Oh, look, I got a whole bunch of angles marked. So I'm immediately thinking angle, angle. So I've got J and J marked congruent. And then I've got K. K has 3 tick marks. Nah, nobody else has 3 tick marks. L has 4 tick marks. Nah, nobody has 4 tick marks. And then B and then C is unmarked. So even though we got a whole bunch of angles marked, they're not congruent to each other. So these two triangles are still not similar. Now, when you do your assignment, you will see that there's going to be 2 blanks for you to fill in. You would type in not similar for both blanks. State the theorem. Oh, this is just awful. State the theorem, if any, that proves these triangles are similar. Write our similarity statement. What I notice is instantly 3 sides and 3 sides. So I'm thinking side, side, side. So I'm going to see, does long over long equal middle over middle, and does that equal short over short? All right, so let's set this up. Let's go long and long. So I find the longest side and the longest side. And then we're going to do the 2 medium sides. And lastly, we're going to do our shortest sides. And for these to be similar, all 3 fractions need to reduce to the same number. So we're going to do yellow over yellow. That's my dogs if you heard them. 44 over 33. Does that equal 40 over 30? Notice I'm going left over right every time. They got to be in the same order. And I know they're in the same order because the left triangle is bigger. So bigger numbers on top, smaller numbers on bottom. So I can divide both by 11. That gives me 4/3. 4/3. 4/3. They all reduce to the same fraction. That's the similarity ratio from left to right. So I know triangle PQR is similar to triangle. All right, so P is where yellow and green meet. Yellow and green. Yellow and green is going to be E. PQ, so I go up the yellow side to Q, yellow and blue. Yellow and blue is F. Green and blue is G. And why are they similar to each other? By the side, side, side similarity theorem. Boom. A lot of times we're going to see what looks like 2 triangles inside 2 triangles. Or 2 triangles inside each other, I'm sorry. So when I see this immediately, what I want you to remember is that angle is congruent in both triangles. So when we set up our sides, here's where we need to be careful. I'm going to do that side, short side, and short side. So I'm going to do green over green, and I'm going to do blue over blue. Those are going to be my 2 fractions that we have set up. Now, once again, I don't care which one goes first, but the second one definitely has to matter. Oh, dang it, I don't know that long green number. Or do I? This is 24. I got 24 by adding 6 and 18. This side is 20. 5 plus 15 is 20. So we're going to do 24 over 18 and 20 over 15. I can reduce both of those to 4 over 3. Divide both those by 5. 4 over 3. Hey, they're the same fraction. So these two triangles are indeed similar. So I'm going to say triangle QPR is similar to triangle QPR. So I did green to P. So I got to follow the same order. X, P, Y. And that's a Y. And they are similar by the side angle side theorem. So what I'd like you to do now, this is going to be our last question. Name the similar triangle theorems. There's 3 of them. Name all 3 of them. And what do we prove with these theorems? What was I proving this entire time? What do the similar triangle theorems prove? Great question. Alrighty, so Patriots, I will be back in class tomorrow. You'll be back in class tomorrow. We will see each other then. So make sure if you have any questions, you come in and ask. If you don't have any questions, let's go ahead and get started on the assignment. You can get it put in and see which ones are immediately right and wrong, and I'll be glad to answer your questions. I'll see you when I see you, Patriots.